Hi, I'm Jay Desai, and I'm going to be leading you guys through the Exploring Algorithms, Searching, Sorting, and Recursion slideshow. So let's get started with the definition. So let's talk about algorithms. So what are algorithms? So think of you're baking a cake, right? So algorithms are a step-by-step procedure or instruction or like a manual of telling you what exactly you need to do in order to get something done. For example, like I said, baking a cake, and that is an example of what an algorithm is. Let's bring up a couple specific algorithms used in computer science. So let's talk about searching algorithms. So they are designed to retrieve any kind of information from like a specific array or list. So what they do is they take that information, all your information you have, and they make it into a list. So then after a searching algorithms takes the information and puts it into a list, we have sorting algorithms. So what sorting algorithms do is that they take all that information in the list and they rearrange it to a specific order. Think of you as like you have a bunch of files all sorted out into a list, but what you want to do is sort it out into a specific category. And that is, for example, what a sorting algorithm would do. Okay, so now let's talk about a couple of real world applications of what searching and sorting algorithms could be used. They can be used across so many different industries and it makes so much users experiences better. So let's get into some of the specifics. Okay, so for example, organizing files, like I mentioned before, being able to locate them quickly. And then this one is actually pretty cool. So you know how we all watch shows, Netflix, right? So when we go to look for a movie or a show, we see how the different movies are organized in different sections. And just like that, that is an example of sorting algorithm. There's different genres where we could scroll through and pick which one we want to watch. Is an example of how we use sorting and searching algorithms in the real life world. Okay, now for the fun part. Let's get started and move on with our activity. So today we're going to be doing the introduction to recursion, and we're going to be using the Tower of Hanoi. So let's get started and let's talk about the objective. So the objective is all the students will be challenged with solving the Tower of Hanoi. And this is going to get them started on the topic of recursion, as students will have to take a certain problem and use smaller steps in order to break down the problem into and get it done in a simpler way. If that doesn't make as much sense right now, I will show you guys with the example. Okay, so all we're going to need for this is a computer with internet connection, which I'm guessing you all have. And then what we want to do is we want to open this link and open up the Tower Hub Hanoi. Okay, once you guys have this open, let's talk about recursion before we get started. So recursion is having to do a task, is having to do a smaller part of a task over and over again in order to get a bigger task done. So for example, this makes bigger problems, which are super complex, a lot easier as we just need smaller and smaller steps and makes it gives us more manageable problems. So for example, now let's talk about a couple examples that make recursion a little more simple. Okay, so let's say we have a big stack of dishes that we want to clean. And obviously you cannot clean the whole stack at once, right? You have to do smaller, you have to go smaller and smaller in order to get them done. So what you want to do is you want to start with the smallest plate and then you work your way down in order to get the process done quicker and more simpler. So for example, this is a example of recursion. Instead of cleaning all of the dishes at once, we get to clean plate by plate. We go from smallest to biggest. That is how we use recursion in the real life world. Okay, now the exciting part. What is the Tower of Hanoi? So, as I mentioned before, the Tower of Hanoi is a puzzle that has three pegs and a certain amount of disc on each peg. So, what we want to do first, so the puzzle is going to start with three discs stacked on the first peg in order from smallest to greatest. So, the challenge of the whole puzzle is to get all of those three discs you have on the first peg all put on the third peg. But there obviously are a couple of rules. We can only move one disc at a time. We cannot put a disc on top of an empty peg or on top of another one. And then obviously no bigger disc can be placed on top of a smaller disc. So it has to be in a smallest to biggest order. Okay, so hopefully you guys have this link open. If not, I'll give you guys a second to open it up. Okay, so before I give you guys, I'll show you guys how to do it. I want you guys to all try it out. So try to move the first three discs from the first peg to the third amount of peg, and at least try to do this in 7 moves. And if you do, good job. If not, I will go through and show you guys how to do this puzzle. Okay, so now that we have the Tower of Hanoi open, say first what we want to do is take this smaller disc and put it on the third peg. Then we take the second disc, put it on the second peg, and then we want to take the first disc and put it on top of the second one in order to get the third biggest peg on the third peg. So that's the final place that we want to put it. Now, this is an example of recursion right here. So we're going to take the smallest peg, put that on the smallest disc, put it on the first peg. Now we want to take this second smallest disc and put it on the third peg. So now those are finalized. Now here comes the final step. All we want to do is put the smallest peg on the smallest disc on the third peg, and now that's it. We have the whole Tower of Hanoi complete in 7 steps. Okay, so now let's talk about the solution strategy and talk about why this works. Okay, so for example, if you only have one disc, you just move it directly from the first to the third peg. That is easy because you don't have to worry about the other disc. But now what we did, let's talk about what you have to do if you have more than one disc. So what you want to do first is move the top and -1 disc to the second peg. So imagine you have 3 discs. You need to move the first to the top 2 discs, the smaller one, to the second peg. And you use this directly, the third peg as a direct helper in order to do this. Then what you want to do is move the largest peg to the largest disc to the third peg. And that is where it's finalized. And then after that, we want to move the n-1 disc from the second peg to the third peg. And then finally, now the 2 discs that you have moved to the second peg, you move them to the third peg, and you can use the first peg as an helper in order to do that. And this works because moving the smaller disc first helps to get a clear way for the largest disc to be moved to its final destination. And after we move the largest disc, you could then use the second peg as a helper in order to rearrange the smaller disc into the correct position. And this is almost like building a tower, right? And you want to make sure the space is clear before you keep building. For example, here, we move the top 2 discs. We start by moving the top 2 discs from peg 1 to use peg 2, and we use peg 3 as a helper. And then we first move the smallest disc to peg 3, then we use the middle-sized disc to peg 2. And then finally, we move the smallest disc from peg 3 to peg 2. Now, let's talk about moving the largest disc. So then what we want to do is we want to move the largest disc directly from peg 1 to peg 3. So that finalizes the spot of that. And then this is the final step. We just want to move the 2 discs to peg 3. So finally, we move the 2 discs from peg 2 to peg 3. And then we use peg 1 as a helper. So we first move the smallest disc to peg 1. Then we move the middle-sized disc to peg 3. And then we finally move the smallest disc from peg 1 to peg 3. And then by breaking down the problem with the smaller steps and moving the discs in an order, this is how we could successfully solve the puzzle. Okay, now let's get on and talk about a couple of discuss questions. So I want you guys to answer this first. And if you're having a little trouble, don't worry, I'm here to help. Why do we use recursion? And could it be used in searching and sorting algorithms? If so, how? Okay, so you guys can pause the video here and answer these 2 questions. If not, let's answer them now. So why do we use recursion? As we've talked about like a couple minutes ago, we use recursion in order to break down bigger problems into more small and manageable problems. It makes our life easier, and it makes the building, like if say we're building something, it makes that easier in order to take smaller steps in order to accomplish a bigger goal. Now, this question could have been a little bit more tricky. Could it have been used in searching and sorting algorithms? If so, how? The answer is yes. So in sorting algorithms, for example, like merge sort, recursion breaks down the list into smaller parts sorts each part out, and then combines them back together. So for searching algorithms, for example, like a binary search, recursion repeatedly divides the list in half. It checks that each element and narrows down to search until the largest or the target is found. So for example, say we have like a bunch of different elements, right? And we want to sort them out. So what we use recursion to break the steps into to break the information into smaller sections, so then we could easily analyze each section a little bit smaller and a little bit more simpler. And then yeah, so I hope you guys had fun learning about the Tower of Hanoi. See you next time. Make sure you guys stay updated. If you guys want to link to our website, Instagram, or YouTube, they're all here. And I thank you all for coming. Bye. Thank you.